Let's get started, guys. On Wednesday, we talked about and we developed codes for calculation of American type options. There's a third type options called Asian type options. These are options where payoff depends on the average, some type of average during the life of the option. For example, an Asian call option, and there is no early exercise. I mean, there can be, but there is no known method of being able to do that easily. Asian call option pays off max of 0 versus S bar minus strike, where S bar is an average price during the life of the option. One of the reasons this is called Asian, it's actually rather popular in Japanese and Hong Kong and Singapore markets. And Asian options, everything else being the same, are cheaper compared to European or American options. And there's a good reason for that. For European options, for example, European options, payoff is maximum 0 versus ST minus strike, where ST is the price at expiration. Consider an option duration of, let's say, 1 year. For example, if option duration is 1 year, there are roughly 252 trading days during the life of the option. Or 52 trading weeks. If we are to calculate average of the weekly closing prices, standard deviation of the average is a lot smaller than the standard deviation of the closing price at option expiration. The idea is kind of simple. For asset prices in general, returns during short periods of time tend to be either uncorrelated, or if they are correlated, those correlations are very small. That means average numbers are a lot less volatile compared to any given one. Let's kind of do a simulation. Suppose mean drift rate equals interest rate, and let's call that 4%, and sigma equals, let's call it 30%. Then returns are what we call log normally distributed. Returns are normally distributed. With mean about 4% per year, and standard deviation of 30% per year or per week. Returns are normally distributed. It mean 4% over 52. Let me call that times 100. So that's 0.0769%. And standard deviation of 30 divided by 52, square root of 52. No. Yeah, divided by square root of 52, which is about 4.16%. If weekly returns are uncorrelated, standard deviation grows at a square root rate, not linearly. So let's kind of do a simulation. Let's do current. I'm going to make that price equal to 1. Week number 1. I'm going to do 52 weeks. Come on. So let's simulate a draw from standard normal distribution. Norm S imp rand. That function, that formula is going to make a random draw from standard normal distribution. Normal distribution will mean 0 and standard deviation of 1. Okay. Now I'm going to let's make this parametric. Today we'll do these simulations on the sheet. On Wednesday we're going to actually write VBA code for it. Because for teaching purposes the sheet is nice, but for the implementation, sheet is a horrible idea. Because usually you want to do a lot of replications of these. If I do that in the sheet with a lot of formulas, it's going to take a while to actually calculate the formulas. Let's call this drift. These are my inputs.